Hi all. Today we are going to discuss motion chapter. First we will see what is rest and motion. What do you mean by rest? The body. You know that rest means it's it will be at the same position or not uh, changing or not moving. So we can define a body is said to be in a state of rest when its position does not change with respect to a reference point or with respect to time. When we check after 3 seconds 4 seconds also, the body will be still in that position or not changing its position, then we can say that the body is at rest. Now then what will be its motion? Motion means what? Its movement or body is changing its position from one point to another. So we can define a body is said to be in a state of motion when its position change continuously with reference to a point or with reference to time. Like in 1 second the body is at this place, and another 1 second the body changes from one point to another. Or if there is a movement, then we can tell that the body is in motion. So now we can see some examples of rest. Electric pole, factory, house, then buildings. Okay, all this you know that it will not change its position, it's fixed. Okay, these are the examples of rest. Examples of motion: flying bird, swimming fish, moving car. Okay, then running, if a boy is running, then satellites revolves around earth, solar system. Okay, all are the examples of motion. The moving or the those one changing its position. Now this is one activity for you. You have to find out more examples of rest and motion and note it on your notebook. We discussed already some examples. You find out more from your surroundings. Now you already learned in small classes like different types of motion. Okay, we will just have a look about this. First one, circular motion. Circular motion means if the body is moving in a circular path, or if the body makes a one circle, then we can tell that it is in circular path. The linear, if it is a straight line path, body is moving in a straight line. Then oscillatory or vibratory, you know that the best example is pendulum. It's a to and from motion, to and from motion from one position to another with respect to origin. Now, we will discuss about scalar and vector quantities. What are scalar quantities? Scalar quantity means it is having only magnitude and no direction. What is magnitude? Magnitude means how much quantity it is. Only we will mention how much quantity. Like we can say that 1 kilogram of sugar means it is only 1 kilogram. We are not specifying about the direction. Okay, so we can write the examples as mass, distance, speed are the examples of scalar quantity. We will deal or discuss more scalar quantities in this chapter. Now, what is vector quantity? If the physical quantity having both magnitude and direction, we will not tell only the magnitude or how much, and we will discuss about the direction also. Or we need both magnitude and direction to describe that physical quantity. Then we will call it as vector. Example, displacement. You know that simply if we are telling distance, we will tell that the it traveled 1 kilometer. But in the case of displacement, we have to tell which direction also. Then only we can find out. Okay, so if it is going and coming back to the same direction, then it will be 0. So for finding displacement, we need direction also. Like that, quantities it required both magnitude and direction to describe. That is called vector quantity. Another example is velocity, force. These are the examples. We will deal this all in detail the coming. No. Okay, what is distance? Distance means it is the actual path or the total length traveled by the object. Suppose a body is started its journey from A and going to these all places and reached at B. The total length or how much path it is traveled, it is called distance. And we discussed already it is a scalar quantity. Here we are telling only the magnitude or how much length or total length. So here one example is given. Uh, a boy is riding a cycle from A to B and reaching at C. Okay. So what will be the total distance here? From A to B he is taken 4 and from B to C taken 3. So the total distance we will get 4 plus 3 7 meter. So this is the distance, the total length or actual path traveled by the body. Okay, coming to displacement. Displacement means the shortest distance between initial and final position. So we can take the same example. The body is traveling from A to B, B to C. But you know that this is the longest path. If he is taking shortcut, A is the initial position and C is the final position. We can draw a line like that. So this will be the shortest distance or the straight line path between initial and final position. And here this length A to C is the displacement. You will get displacement as 5 meter. Okay, it is a vector quantity. It restrains both magnitude and direction. So here you will get one summarization of what is distance and displacement. So A to B, the actual path traveled by the object. That is what it is. It is distance, and the shortest distance between initial and final point or the straight line path, that is called a displacement. So this is the table showing the difference between distance and displacement. Okay, first we can tell what is distance, the total length or actual path traveled by the body. Displacement is the shortest distance, and the distance is a scalar quantity, only magnitude. Displacement is a vector quantity, and distance is always positive. We are telling magnitude always positive, but displacement can be 0. We will discuss where the displacement will be 0 and all. It can be negative also. When it will be negative, it will be in the opposite direction. Okay. Then distance, it will be always greater or equal to displacement. We know that if it is shortest distance means it will be equal, and if it is other cases, displacement always taking shortest or the least path, no. So distance is always greater or equal and displacement is less than or equal to distance. And SI unit, what is SI unit means? The system of units is to describe. So you know that distance and displacement, both case we will measure length. So both the case SI unit is meter only, and the distance it will not decrease with the time, but displacement can be decreased with time and it can be 0 also. Okay, this is very important, please note it down. Now in that table we saw that displacement can be 0. Okay, where displacement can be 0, here one example I am giving. Suppose a particle moving in a circle and makes one complete rotation. The particle started from A and makes one complete rotation and comes back to A. So the total distance, you know that it is traveling along the circumference of the circle. Circumference, that is 2 pi r. Then what about the displacement? So it is, you know, that shortest distance between initial and final point. Here the initial and final point is same. So the displacement will be 0. So you keep it in mind. If the initial and final point is same, or if the particle starts journey from a point and also reaches back the same point, that case the displacement will be 0. So in the case of circular motion, if it is make one single rotation, so that is also displacement will be 0. Now we will see what about semicircle. Semicircle, what about the distance and displacement? Can you tell? So you know that the total, in the case of circle, the total distance is 2 pi r. Here the half only, semicircle. So distance will be 2 pi r divided by 2. So distance you will get it as pi r. Then what about displacement? Displacement, you know that it is the shortest distance. Here initial and final point is not saying here is A, here is B. You know that suppose this is the part of circle and this one is called a diameter. Okay, so displacement will be the diameter, and displacement we will get a diameter. How to find out? 2 into radius. So here the displacement is 2r. Then in the case of straight line, suppose a particle is traveling in a straight line, you see that shortest distance also same, total length traveled also same. This is very important point. In the case of straight line, distance is equal to displacement, or distance and displacement are same in the case of straight line motion. Questions are asked based on this. In which motion distance and displacement are equal, and they will give options like straight line, semicircle and all. What is the answer? In the case of straight line motion, distance and displacement are equal. Okay, I hope you got this point. Now coming to the next point. Okay, we learned so many types of motions in the previous classes, like circular and all. Here in this chapter, we are going to discuss mainly about uniform motion and non-uniform motion. What is uniform motion? You can see one picture here. After 2 seconds, the body is traveling 4 meter. Then after again 2 seconds, 4 plus 4 8. Here 4, here 4, here also difference is 4. So each 2 seconds, this body is traveling 4 meter. Okay. So like that, if the body is traveling equal distance in equal interval of time. Okay. Each 2 seconds, the body is traveling 4 meter. Isn't it? So we can define uniform motion as when the body travels equal distance in equal interval of time, then the motion is said to be uniform motion. Okay, the interval of time is equal. If we are taking same interval of time, the body travels equal distance, then we can tell it as it is in uniform motion. Then you see this example. In 2 seconds, here body travel 1 meter, and next 2 seconds the body travel 10 meter, and next 2 seconds the bodies travel 10 to 25, 10 plus 10, 20, 15 meter. So is this body is traveling equal distance? No. It is traveling, the period of time is same, isn't it? We are considering each 2 seconds. Okay, if the bodies travel unequal distance, but the equal interval of time, like in the first second it travel 1 meter, second 10 meter. Like if when the body travels unequal distance in equal interval of time, then the motion we can said to be non-uniform motion. Here you make it correct. When a body travels unequal distance in equal interval of time, then the motion is said to be non-uniform motion. So now we can discuss some questions based on this. Here one paragraph is given. You have to read that paragraph and try to answer the questions given. Okay, this questions given is very easy, only what we learned already. Distance is the length or actual path traveled covered by an object irrespective of its direction of motion. Displacement is the shortest distance between initial and final position of an object in the given direction. Distance is a scalar quantity, or displacement is a vector quantity. Distance covered can never be negative, it always positive or zero. Displacement may be positive, negative or zero. So my question is, dash is the actual path covered by an object. In the paragraph itself it is given. Sometimes the answer will not be in the paragraph. You have to check it, or you have to find it. But in this case, the answer is given in the paragraph itself. The distance, okay, is the actual path covered by an object. So option D is the correct answer. Next question, dash is the shortest distance between initial and final position of an object. The shortest distance, that name itself you will get displacement. There is displacement. Which of the following is a scalar quantity? Which of the following? Yeah, you sure? Distance is a scalar quantity. Displacement, velocity and acceleration all are vector quantity. Now I'm giving one question for you to work out. Find out the distance and displacement if the boy completes one route. So boy is starting his journey from A to B, B to C, C to D, D to A. He is coming back to the same position. So what about the distance? Distance means total path. That is 3 plus 4, 5. Okay, 3 plus 5 plus 3 plus 5. What will be the distance? Yeah, 5 plus 5, 10. 10 plus 6, 16 meter. So distance is 16. What about displacement? Here you can see boy started from A and he again came back to A. The initial and final position is same. So here displacement is 0. You can write displacement is 0 and you have to write the reason also. Why? Here the body or the boy started journey from A and came back to the same position A, or the initial and final position is same. So displacement is equal to 0. So I hope this is clear for you, and note down these questions to in your notebook. Okay, thank you all.